part as we have the second module, but our question was through the help of ping command to examine the operating system. So through the ping command, I'm sending number of 3 packets on the google.com. And Divyan said through the title value, we can identify the operating system. But Divyansh, can you tell me why it's not a fixed length of values? It's showing me 117 and the total was 128. So where are the rest? Yes.
So actually this value got decreased when it passed through number of hops, I guess.
Yes, exactly. The number of hops means the number of devices. Whenever the client, the ping command has passes through a number of devices, which is a hop, it will simply decrease the TTL values also. So the total value was 128. So the total value is 128 and we have 117. It means 11 values has been decreased because the number of devices are 11 in the between the client and the server. So today we're gonna start our scanning part, and over here these are some common you can say common command ports that we should know about. For example, FTP, which is 21, SSH, which is 22, Telnet 23, SMTP 25, TESAC. So can anyone tell me which port number ping command works? Which is echo packet. So we are doing a ping command on the server side, but it should have a protocol. So can anyone define me which protocol they use? The protocol name is echo, but what is the port number?
254.
254. So who is it?
Yatin.
Yatin. So you are wrong, Yatin. That is protocol's port number 7. 254 is the number of devices. I said the ping command has using a protocol, which is your echo protocol, echo, which works on a port number, and that port number is 7. Check this one. Over here, the total number of ports are 65,535 ports that works. The FTP port works on 20, also on 21. SSH port 23, SMTP 25, 42 is your WINS replications, 43 is your WHOIS. DNS, which works on the port number your 53, 67 and 68, which is your DSCP. And 53, with the port 53 is also a question, is it a TCP or a UDP port? It's at both TCP and UDP port. So the very first thing over here to understand the scanning part, we should have go through the common ports, which port works, which services. So our major concern that we're gonna do over here, we're gonna start with the scanning part. So after footprinting, we have the scanning part, which is totally active method. So it's an active method. And this is a part of your information gathering. So as we can see over here on the screen that after footprinting and reconnaissance, scanning is the second phase of hacking, where we have to gather the information about the live host or a specific domain of a network. Scanning is where we dive deeper into the system. This is the important part, dive deeper into the system. But for example, if I have a system in front of me, just do a penetrate of this. I need to check all the possibilities one by one. For example, the 2 things which I told you yesterday, that was banner grabbing and fingerprinting. Banner grabbing is a process where we need to identify the services and the specific version which is running on the server side. And fingerprinting is a process where we need to identify the OS type. So you can see over here, why should we scan the system deeper? Because for the valuable data, the services and the specific IP address range. In the scanning part, what do we have to do? We have to identify the live host, the open ports, the services, the OS, the network scan, and the vulnerability scan also. See, These are the things that could be happen over there with the help of scanning part, and these are the majority, and these are important topics. Note it down in your notepad or your copy to remember. And the most important thing, when you're simply scanning someone's server, think about the OSI model. And that works on the type of protocol, which is your TCP protocol. If you talk about the type of scanning, think about this one. TCP, Transmission Control Protocol, which is basically used for making a reliable communication between the two nodes, a client A and a client B. It is used for a wide variety of protocols on the internet and contributes to a reliable communication with the help of three-way handshake. So for example, they have given us three-way handshake. So how the three-way handshake works? They have given some HTTP flags. Some HTTP flags, like just like your sync flag, your ACK flag, your RST flag, your FIN flags. So anyone can tell me about these flags? What are these flags means over here, and what are their functionality in the real life scenarios? Anyone?
Sir, repeat करना सर एक बार.
मैं पूछ रहा हूँ कि थ्री वे हैंडशेक के बारे में कोई मुझे बताना चाहेगा कि थ्री वे हैंडशेक किस लिए यूज होता है?
सर थ्री वे हैंडशेक सर टीसीपी के कनेक्शन के लिए यूज होता है सर. जैसे पहले वो सिंक्रोनाइजेशन पैकेट भेजता है सर्वर को क्लाइंट, और फिर वो एक्नॉलेजमेंट और वो भेजता है. मतलब
आगे बोलो.
सर मुझे थोड़ा बहुत कंफ्यूजन हो रही है इसमें. जो सिंक्रोनाइजेशन पैकेट होता है वो क्लाइंट सर्वर को भेजता है, और फिर वहाँ से एक्नॉलेजमेंट और सिंक पैकेट आता है क्लाइंट के पास, और फिर ओके मैसेज जाता है कुछ सर्वर के पास.
ओके, सो तुम्हारे सामने ही कुछ लिखा हुआ तुम देख रहे हो. जो आप बोल रहे हो ठीक है, बट मैंने पूछा था कि ये फ्लैग्स करते क्या है. सिंक फ्लैग आपका एक इनिशिएट कनेक्शन बनाता है, एक रिक्वेस्ट होती है फ्रॉम सर्वर साइड और क्लाइंट साइड. एक्नॉलेजमेंट का मतलब क्या होता है कि यस आई रिसीव द पैकेट फ्रॉम द सोर्स एड्रेस. RST means reset the connection. FIN means terminate the connection, which means cross session out. अगर मैं बात करूं सिंपल यहाँ पे, जैसे आप ब्राउजर ओपन करते हो, फॉर एग्जाम्पल द फर्स्ट मेजॉरिटी इज हाउ. अगर मैं यहाँ पे google.com कर रहा हूँ तो बैकएंड प्रोसेस में क्या हो सकता है? बैकएंड प्रोसेस में वही थ्री वे हैंडशेक, TCP. तो मैं इसको चेक करने के लिए यहाँ पे वायरशार्क यूज करूंगा. सो वायरशार्क जो आपका यूज होता है वो आपके नेटवर्क मॉनिटरिंग टूल है. तो ये जो टॉपिक है आपका वायरशार्क, वो भी आपके अपकमिंग सेशंस पे आएगा. सो लेट्स हैव अ लुक. So let's try google.com again. Let's try facebook.com या youtube.com. So the packet has been captured over here. तो अगर मैं बात करूँ यहाँ पे DNS जो हमारे डोमेन नेम सर्वर हो गए, ये देख रहे हो, facebook.com, google.com, जो कि रिक्वेस्ट कहाँ से बनी है? मेरे खुद के आईपी एड्रेस है जो कि मेरा 110 है. बस स्टॉप कर देता हूँ. 110 से एक रिक्वेस्ट बनी है किसके ऊपर? पहले राउटर के पास गया है, और राउटर ने से कैरी फॉरवर्ड किसको किया है? फेसबुक को किया है. जो 110 यहाँ पे देख रहे हो सोर्स, ये मेरी खुद अटैकर की आईपी एड्रेस है. So the majority comes over here. When you are simply doing a simple google.com or a facebook.com, think about the backend concept. And think about the three-way handshake also. Three-way handshake is a process in which, in the TCP/IP network, to make a connection between a server and a client. It is a three-step process that requires both the client and server to exchange synchronization. Synchronization means connectivity, and the acknowledgement packet before the real data communication process. So let's have a look. How does it looks like in real scenarios? So what we have over here is a proper three-way handshake. Yep. So we have a client and a server. So when we are simply sending a request to the server side, we send a synchronization packet. State change to synchronization state, which is a sequence number. Sequence number is your offset memory. Each and every value has an offset, which is your registry. When a client is sending a request to the server side, it will send a synchronization packet. When the server received a packet from an unknown source, the unknown source means they didn't even know which source came from. It's gonna check the IP address which belongs to that packet. और जब भी आप एक पैकेट भेज रहे हो, जैसे कि यहाँ पे देखना, सोर्स एंड डेस्टिनेशन, सोर्स जो कि मेरी खुद की आईपी एड्रेस है और डेस्टिनेशन जो कि मैं जिस पे भेज रहा हूँ डीएनएस पोर्ट नंबर 53. और अगर आप यहाँ पे देखो, you will get a proper details of the source and the destination. देख रहे हो, सोर्स किसकी आईपी एड्रेस है 192.168.0.110, that is mine IP address, and the destination was our router which is carry forward to the facebook.com DNS. So अगर आप यहाँ पे देख रहे हो कि जब एक सर्वर एक क्लाइंट रिक्वेस्ट को रिसीव करता है तो उस सोर्स पैकेट में उसका एक एड्रेस होता है आइडेंटिफिकेशन करने के लिए. So then the server will accept the packet which is a if he accept the packet, he will send a synchronization packet also from his side and an acknowledgement packet. An acknowledgement packet indicates that the packet was received. And then a proper reliable communication between the client A and the client B. First client will send an acknowledgement packet. Yes, I also accept your request. So we can simply communicate in the proper values. So that's why अगर आप यहाँ पे facebook.com कर रहे हो, google.com कर रहे हो, तो remember in the backend process कि आप 3-way handshake के through ही जा रहे हो. And there are lots of further things. See over here. The first host sends a sync packet to the second host. The second host responds with a sync packet. It indicates that the packet was received. The first host completes the connection by sending an acknowledgement packet. And you can see, which I already mentioned you, these packets should be over there. And one more thing, we're gonna use some tools over here, just like your Nmap, Nmap, some net discover, some other different kinds of tools. So we're gonna check one by one all the possibilities, and I'm gonna use my vulnerable machine over here. That would be my metasploitable. So this would be our vulnerable machine. Because we need a host to scan. So over here, MSF admin is the username, MSF admin. Yep, ifconfig, and we can see the IP address is 124. So let's have a look over here. So over here, you can see that we have an IP address on our network. Our major objective is to identify the live host. First, we're gonna try all the things one by one. Any questions, guys?
No, sir.
Okay, so I would you like to tell you about all the things? Please mute your mic so we can continue. So the major perspective, we're gonna try one by one all the possibilities over here. So the first thing first is to scan the live host. So let's have a look on my Kali Linux. So for the live host, we can see on the application over here. So we have information gathering, we have Dimitri, iScan, Multigo, Net Discover. So we're going to use the very first tool, which is our Net Discover, to identify the live host in our entire network. Or I can do one thing. If you doesn't know about the tool name, just do man, which is your manual, and the tool name, which is your Net Discover. Through the manual part, you can identify which is the description is given over there. NetDiscover is an active passive ARP reconnaissance tool, initially developed to gain information about wireless network without DHCP server in wandering scenario. Wandering scenario is just like your monitoring mode. It can also be used to switch networks built on the top libend and the libcap. So through the NetDiscover, we can identify the number of hosts in our local network, and it basically works on the subnet of 8, 16, and 24 only. So let's have a look. The first thing first, we need our gateway IP. That would be my route -n. So through the gateway IP, I can see 192.168 is my 0.1 is my gateway IP. So why we need our gateway? Because all the network devices are connected with this specific IP address, which is over here, which is seen over here. So let's have a look in this scenario. So let's use some cheat sheets over here. So over here, we're going to use some subnetting part. So as they mentioned, NetDiscover basically use 8 bits. If we're using 8 bits, it's going to scan 1,67,77,214 hosts. If we are using 16, then it's going to cover 65,535 hosts. If you count 24, which covers 254 devices. And we're going to use 254/24. Why? Because in a single router, the 254 has the highest limit of the network devices can be connect to the specific domain or a network. So what I'm going to do over here, you can try to use /24. It depends on 16, it depends on 8. So remember how to use which subnetting part. So we're going to use NetDiscover -i. -i stands for your network interface. So right now, my network interface is ETHO, which is Ethernet. And over here with the IF config, you can see that we are using ETHO over here also. So we're gonna use this one for network monitoring part. So I'm gonna use Ethernet. -r is for a specific range, and we're gonna give the range of 192.168.101/24. So over here, you can see the number of devices which is over here on the screen, which is 192.168.0.1, 104, 124. NetDiscover -i, ETHO -r 192.168.0.1/24, and then you can see this is the IP address, the MAC address, which is given over here, the unknown vendor. The MAC address ARP reconnaissance is basically using ARP protocol, ARP protocol, to identify the number of hosts on the network. So you can see 104, which is my base machine IP address, which is my Ashutech, and 124, which is my PCS machine. That would be our victim machine over here. This would be our victim machine. So my major concern would be, if we have a target, how we can gather more information. For example, there are various techniques that you can use it to identify the live host on the network. You can use ARP address resolution protocol, which is basically used to identify the live host also and check the ARP cache tables of your router device. -a host, all host. It's going to show only the router, which is right now 192.168. We can use ARP scan also. Okay, I guess I don't have ARP scan in my local server. Or we can try different techniques. The only thing which I can see with the cache memory of my router, I can see only router device. Sometimes you will get the output or not. It depends on the network part. But through the NetDiscover, you can identify these are the number of devices which is connected over there on my local network. And over here, Just you have to use the specific IP address, the range which is given over here, and the subnet part. The live host can be discovered in many ways. So for example, I have a tool called Angry IP Scanner. You can download Angry IP Scanner from Google. For example, you can visit over here and just type Angry IP Scanner. You can see the very first one. Angry IP Scanner is also one of the tools which is used to identify the number of devices on the local network. Download for Linux, I guess. DB package, RPM package. So remember, Debian package and RPM package are totally different. Debian packets are work when your Ubuntu and your Linux machines or your Debian based. And ARP packet, which RMP packet, which is works on the different operating systems, just like your Fedora, your Red Hat, your Magnia, your OpenSUSE. To check if you're capable for the Debian packet or not, you can simply check your kernel version. You can write uname -a, and you can see over here AMD 64. You are using 64 architecture with the Debian source. So major objective यहाँ पे क्या है कि आपको simply you have to specify these capabilities over there one by one. For example, अगर मैं बात करूँ यहाँ पे, we can use Linux machines. You can download this one, but I already have downloaded this one on my local server, and over here you can see. In this Angry IP Scanner, you can use it to identify the live host on the local network and some different other techniques. For example, you can see over here scan, next live host, next open ports, dead host. You can check all the things one by one. Show details. You can see the commands over here. Which one you want? Do you want to do a web browser or FTP or a telnet or a ping command? The who is geolocate or email sample? You can try to use all these things one by one. Add current tools. So you can use fetcher. Fetchers are basically a utility on the Angry IP Scanner, which is basically used to check all the capabilities, just like the filter ports. It's going to scan the filter ports, the web detect part, HTTP sender, comment part, packet loss. If the packet has been lost, it will show you all the things. HTTP proxy, MAC address. So over here, I have selected ping command, host names, ports to scan, TTL to scan, and any of the NetBIOS scan. You can simply remove it, or you can simply include this one. So our major objective that would be going to do over here, we're going to put our subnet mask that would be over here. 192.168.0.1 IP range to 254 devices, and you can select IP range or random or something else. 254. Yes. Anyone?
Please repeat. Like my net connection was unstable. So please repeat कर दीजिए.
So who is it? Please name first of all, guys. क्योंकि मेरे पास इतना टाइम नहीं है. सिद्धार्थ. Yes. तो मैं ये बोल रहा हूँ कि जो IP रेंज आप यहाँ पे स्पेसिफाई करोगे वो आप अपने राउटर से लेकर 254 डिवाइसेस तक दोगे. और यहाँ पे जो फैचर यूज कर रहा था ये आपके पूरे पिन कमांड, होस्ट नेम, कोड स्कैन करने के लिए, टीटी वैल्यू चेक करने के लिए और नेट बायोस चेक करने के लिए यूज हो रहा है.
Okay, sir.
So यहाँ पे स्टार्ट करते हैं. So it's going to scan all the number of devices, all the number of IP addresses on the server. That would be your 1 to 254 devices. So our major objective of this is to identify the live host. You can see their total number of devices are connected over here is 5. Check this one. The red ones are the dead ones. 100 and 100, which is a host over there on the network. TTL value 64, it means it's a Linux machine. 103, which is also a Linux machine over here. 110, which is also a Linux, which is my IP address, Kali. We can see 124, which is metasploitable, and the port is 80 open, and this is also a Linux machine. You can simply check one by one all the things, show details, rescan, delete scan, copy the details, or you can try different kinds of things over here. Our major objective of this scan is to check all the possibilities one by one. Is it clear to everyone? Either we can use NetDiscover, either we can use Angry IP Scanner to identify. But there are various other techniques that we can use it for our scanning part. For example, we can try all these things with the help of Nmap also. So let's close this one and let's go to the application part and let's see information gathering. So what do we have over here? We have Nmap also, we have Znmap also. Nmap is your command line, and
And
Znmap
Nmap
GUI. So over here, we're gonna try with the Nmap over here. So before Nmap, as I mentioned, you kindly do men Nmap. If the tool is new for you guys, try to use men before any of the tools, which stands for manual. So Nmap is our network mapper, which is basically used to identify the number of devices on the local network, and basically it's used for auditing part, network security auditing part. And Nmap is your VA tool, not the PT tool. It's a vulnerability assessment tool to figure out the loopholes which is present on the server side with the help of scanning the protocols and the services. Each and every protocol has a service. That's why we have to use all the possibilities. You can visit the website nmap.org. This is the website where you can visit and to learn more advanced things. You will get all the guides that you want. Or if you don't want to go over there, just write Nmap any medium report. You will have lots of guide of ethical hacking with the help of Medium website. Everything is open source and open to all. Nmap Network Mapper is an open source software that is used to find vulnerabilities on the network by scanning through different ports. Port scanning is a map port functionality, but is also can be used to collect characteristics of a network that services are being run and their version number, and the operating system being used, and whether there are firewall rules and packet filtering. See, this was the important part. You can visit nmap.org. They have given a website, or you can simply check one by one all the possibilities. Host discovery at a ping command. So let me show you one thing before going to this part. Check this one. When you're doing Nmap scan, you will see some output like this one. There will be some ports, there will be some state, which shows you open, close, or filtered, services, the protocol which is running over there, and the specific version. As I mentioned you yesterday, the banner grabbing part. The banner grabbing part is your SSH and the specific version which is running on the server side. And there are various techniques that can be used one by one. TCP open SSH 5.2.1. And the banner grabbing part is where you need to identify the OS type. See, this one was I talking about. To identify the services plus their specific version which is running on the server side to identify the type of attack. So before the attacking type, think about it works with the help of three-way handshake. And remember, when you're doing some Nmap scan, you will see something like open, filtered, or close. So what are these states? So let's have a look on my notes. So some port status type they have mentioned. If you can see the port is open, it means that an application is running over there. If you see the closed, none of the application is running over there. Filtered means the port is beyond the firewall. The packet has been filtered. Unfiltered, Nmap are not able to recognize if the port is open or closed because it's been unfiltered. And unfiltered will be rarely, very rarely thing will happen. So our major objective of the Nmap scan is to check all the possibilities one by one to identify the services and their specific version which is running on the server side and which will be helpful us for information getting. So let's have a look on the Nmap scan. Now we're going to check Nmap. So you can see nmap.org is also given over here. So users, Nmap, your scan type, your options, your target, specification. See. The scan type, the Nmap is a functionality. Scan type would be like your LL, IR, execution, or SL, SN. The options will always available over there. And the target specification, which would be your IP address. So the very first thing we're going to try one by one all the possibilities. Let's try with the target specification. So over here, you can use Nmap. Example, you can give the domain name, or you can give this domain name with a /24, or you can give the IP address, or you can specify the IP range. If you have a number of list of IP address, you can put input file name, which contains all the number of IP address. IR, the number of hosts. So let's have a look. Nmap 192.168.1.0.124. I'm going to scan only one server. That would be my 124, and I can see how many ports are open there. You can see total number of ports from the T21 to port 8180. FTP is open, SSH is open, Telnet is open, SMTP open, domain, HTTP. The number of ports are open. It means the number of vulnerabilities might be there on the server side. And there are lots of things can be happening. So our major objective is to simply enumerate the services that can be used for information gathering part and which can lead us to proper exploit. Or I can do Nmap and we can give the subnet mask. So it's going to take some time because you have put /24. It means if in that specific domain, yeah, see, first you scan the router to identify the port numbers. That was port 22 was SSH is open, 53 is open, port 80 is open, 104 which is my Ashutek, 443 is open, SSL, 902 is open, 192 is open, 5357, it's open over there on server. And the last on the list we have our 124 that was already scanned. So 110 also, which is my Kali Linux. So the very first thing is you can specify the target, just like a domain name. You can specify the domain name also, or you can simply give IP address. Domain name like your nmap test.php, test.php.oneweb.com. This is a domain name. A proper domain name is given over there. And it's gonna scan the entire network. See, over here a proper IP address has been given. 21, 22, 25, 53, 80, 106, 43, 465, 993. See, this is a specific real website. So our major objective that we can use it for specifying the target type, or we can try the different kinds of possibilities over there. So let's have a look of all the application that is used in the Nmap scan. So we're gonna use the next scan is our host scan, the host discovery. So we have already done the host discovery with the help of NetDiscover. We have done the NVIP scanner also. Now let's have a look with the Nmap. So how we can use Nmap with the host discovery. So we're gonna use SL command, list scan, simply list target to scan. So if I'm using the list scan, for example, Nmap small s capital L and the subnet mask, it's gonna show you all the number of devices that you have to scan on that specific network. And that would be from, see, there is a machine called 113, that is like a Petrix. So the total number of devices on my network can be connected is 254 devices can be connected. But our major agenda, we're gonna use SN component, ping scan. Again, we're gonna identify the entire network device with the help of ping scan. And remember, if we are scanning the entire number of devices, the packet which is flowing from my client machine, it will be sending all the ping requested all over the network. And if any of the network devices had accepted the ping request, it means that the host is live. So let's do Nmap SN 192.168.0.1/24. So over here we can see the SN command, which is also works on the echo protocol, which works on the port number 7, had discovered some of the devices are active over there. And over here you can see these are the active hosts, like your 192.168.0.1, 104, 124, which is my Oracle virtual box, and 110 on my network path. So our major objective of this scanning part is to identify the number of hosts, but this SN command is a simple option or the type of scan that we have selected from the Nmap. So let's have a look on some other options like ping scan. We can use PN also. Sometimes SN command don't work because of the ping blocking. Some of the client will block the ping request. So on that scenario, what we can do ping not. Treat all hosts as online. Skip the host discovery. But there is a functionality on the PN. If you are simply using PN command, to the entire network, it's going to scan the open ports also. 192.168.0.1. If you're using the ping command. Ping command will treat all the hosts live, and it will scan the ports also. Now the major agenda was we are not identifying the number of hosts. Now we are going to identify if any of the hosts has a port number, kindly display it already. So my major perspective that we're going to try over here is to check all the possibilities one by one and the information. There are lots of other commands, just like your PS command, PA command, PU command, and PY command. And what exactly those function means. Remember the TCP, the UDP protocols. The TCP protocol is basically used to make a reliable communication with the two clients. And the UDP protocol is basically used to live streaming or sharing the data between the two nodes. PS, which is your TCP Sync Scan. PA, which is your acknowledgement packet. PU is for UDP, and PM for your TCP, discover two given ports. Discover the given ports. So if you are using, you can simply make your own connection. Do you want to send acknowledgement packet? If the server acknowledges that packet from your side, it's gonna give us a proper reliable information. For example, PA command acknowledgement packet. So it means I'm just sending a proper request to the server side to make a proper reliable communication. So through the PA command, I can also see the number of devices. Let's have PS command. PS command for sync packet. All the you will see the outputs. All the outputs are the same, but the functionality, the backend concept to make a reliable communication is different. PE command is for echo command, ICMP echo packet. PP for timestamp. Timestamp is basically used for number of period of time. It's still going on. PM from network mask risk card. If you want to send some echo packet command, you can use PE. But how will you going to examine these things? You can examine all the things with the help of Wireshark. So let's use ip.addr is equal to my IP address, which is 110, and function. We're gonna add some queries. ip.addr is equal to 192.168.1024. Let's have a look between these two blocks. Again, I'm gonna run the command, p command. See this one. A proper request which is transformed from my 110 to 124. You can see only the front end, but in the back end there is something else. The first 110, which is my IP, is sending a synchronization packet to the second host, which is 124. You see, and 124 sending a sync plus act packet to whom? To 110. And it's also sending an RST packet. We reset the connection. Why? Because the packet has been accepted. So if you check all the number of scans over here, you will see some different outputs. For example, there are different kinds of technique that we can use it for the further steps. Let's have a look. Let's try with the sync scan also. Over here, the host discovery, the sync scan is also used to modify the packet's transaction part. Do you want to simply send the sync packet only, the TCP packet, the three-way handshake, or the acknowledgement packet, or the SW packet, or the SM packet? If you want to scan the UDP packets, you can have to use capital S, small s, capital U. Let's have a look. Sync Scan is also known as half scan. For example, TCP Sync Scan. The TCP Sync Scan is a default scan that runs against the target machine. It is a fast scan. You can tweak it make faster by using -n, and that will tell the Nmap to skip the DNS resolution. The source machine will send a synchronization packet to the port 80 in the destination machine. If the machine responds with a sync plus ACK packet, Nmap would know that the particular port is open on the target machine. The operating system would send an RST packet, receive the packet in order to close the connection, since we already know the packet is open. If there is no response from the destination after sending a sync packet, that the Nmap would not know that port is filtered. If you send a sync packet and the target machine sends a RST packet, that Nmap would know that the port is closed. So you can use SS over here, just like this one. So let's have a look. Nmap SS and the IP address. And let's move Wireshark. See over here, the only thing you can see is the SS synchronization packet and an RST packet. RST plus ACK. RST plus ACK means reset the connection and the packet has been accepted. And 110 is sending a RST packet. Please close the connection or reset the connection. The most important thing, you have to understand the proper three-way handshake. For example, let's have a look again. This time I'm going to use ST, proper TCP handshake. See? Sync, SYNAC or ACK. 110, which is going to send a synchronization packet. 124, which is going to send a sync plus ACK packet. And 110 will make a proper connection with the acknowledgement packet. And through this connection, a proper three-way handshake has been completed. If we are making a proper three-way handshake reliable communication, it means we are exchanging our data, which is an ethical way. But before the SS command, it was unethical. So you should know about the proper means that can be used for the further stages for experimental part. Let's try some other techniques. Let's try with the SA command. A proper acknowledgement packet to be sent. Through the SA command, you can simply identify if all the ports on the server side are filtered or unfiltered. You can see all the 1000 acknowledgement ports on the 124 are unfiltered. Why? Because from my server side, I'm just sending an acknowledgement packet and just checking if the port is open or not. See? Our major concern that it would be to check, to analyze the ports and the services over there that will be help us and lead us to a different services. So our major objective of this one is to simply get a reliable protocol and the needs of this. So the major objective, this one, is to simply identify the type of scan. You can use SU. If you are simply scanning the UDP ports, it's going to take some time. It's going to take a lot of time. It means you didn't mention the port number, which UDP port you want to scan. And if you are scanning the entire UDP ports on the network, so it's going to make a lot of time to be scanned because UDP is a connectionless. And it's going to take a lot of time to identify which UDP ports are open on that specific port. Because total number of ports are 65,035 ports. Might be some of the ports are be open or some might be not. So our major aspect it would be to check all the things one by one. See, the time has been increased time by time. So we can stop this one because it's gonna take a lot of time, and we don't have that much of time to simply wait for the output to come because it's a 2-hour class. So, but if from your end, you can try this one for practice. So what we have else? We have some other scans also. We have some null scan. Null scan, there will be nothing over there. It will be an empty packet, SN packet. Null packets. You can see through the null packet, you will not be identify if the port is open or filtered. It's going to show you the ports are open, but he's not aware that is it open or closed. A 50-50 chance will be there. So if you read about the null session, fin, and Xml scans are similar to each other. The major advantage of using these scans for pen tests is for times they get past firewall and IDS, they can be really beneficial against Unix-based operating system. 3 of these scans do not work against Windows-based operating system because they send a reset packet to your list. We cannot be exactly determined if the port is open or filtered. So you can see they have given a proper way that you can examine these things. A null scan is accomplished by sending a no flags bit inside the TCP header. If the no response comes, it comes that the port is open. If the RST packet is received, it means that the port is closed or filtered. So we have fin scan also. A fin flag is used to close a currently open session in a fin scan sender. So it's going to send an HTTP flag, which is a fin tag that can be used to terminate the connection. Xml Scan is just like your other scan, but it's going to add some headers just like your fin flag, your argument flag, and your push flag to the destination. It will lighten the packet just like a Christmas tree, and then it will call an Xml Scan. So what we're gonna do over here, we're gonna try to check all the possibilities over here one by one. So let's have a look. Let's try with the -P, specifying the port number. If you are simply scanning some port numbers, you have to use the capital P. So either you can use -P or the port number, or you can give the range to scan, which is your P1 to P65535 ports, or you can use -P, or U stand for UDP ports and T stand for TCP ports. So let's try a scanning part. Nmap -P. So if you specify the port number, that would be really good for us. So it means your port specifications are illegal. You have to use 100, 200 on a range, or a TCP port, or a UDP port. For example, just search for if the port number is 22 is available over there on the server side node. Warning, the port is not specified. Let's try this one again. Yes, the port number 22 is open over there. Let's try to scan the entire port number. So P-P. P-P means it's going to scan all the number of 65,535 ports on the server side that could be reliable for us. You can see all the ports are over here, and the 3 ports are unknown on the bottom side. Or we can give some ranges over here, just like Nmap -P, scan for 21, scan 22, 23, 25 on the IP address. See, You can specify the port number over here, or you can try to use the fast scan, which is your capital F. Fast mode scan, fewer ports that can scan default. If the port is not getting an output over here, we can use capital F to force the Nmap to find the port is either open or closed. So that's the important thing. So the next topic is your service plus version detection. And service plus version detection is your banner grabbing part. Remember I told you, banner grabbing is an important thing. You should know about the scanning type, how does it works. But the most important thing is your SV to identify the service plus the version information. So let's have a look. Nmap, SV, and the IP address. So ये जो आप SV यूज करेंगे, ये आपका proper 3-way handshake यूज करेगा first of all. So it's gonna be a huge aggressive scan because over here we're gonna identify the services plus their specific version, and that's why through this service plus version we need to identify the vulnerabilities also. अगर FTP version 2.3.4 चल रहा है तो मुझे इसका क्या देखना है? Exploit DB में vulnerabilities देखनी है, public exploit. Okay, let's use public exploit DB. So let's have a look. You can see over here, VSTFTP 2.3.4 has a Metasploit backdoor command execution, which is your Metasploit, and that is your remote code execution. You can read about this vulnerability over here. This is a proper Metasploit code. This file is a part of your Metasploit framework and may be subject for distributions or commercial restriction. Please see the Metasploit framework website for more information for licensing and the terms of use. And there are further things that can be used over here. Our major agenda is to check the possibilities that we have the output. And you have to check all these things manually. So if you find any vulnerability, if you find any of the versions, kindly check on the Google. There will be some vulnerabilities over there that can be used for further stages. And yeah, the Nmap script scan, the most powerful scan in the Nmap part, SC script scan. So let me tell you about this one in a new tab. So let's do cd user share Nmap scripts. Each and every Nmap scripts has a different parts to be scanned. You can try to use this one for vulnerability assessment, for information gathering part. See, there are lots of scripts over here that can be used over here for the further step. For example, I'm going to use this one, assembly vulnerability. Just copy this one, just cat and open. This is a Lua language script. And this has given some buffer memories, but the major objective, attempt to detect if the Microsoft Assembly version 1 is server vulnerable to remote code execution vulnerability, MS17 turn eternal. The vulnerability is actively exploited by the WannaCry and Petya ransomware or another malware. See. The scripts connect to the IPC tree, execute a transactions of FID 0 and check if the error status. It is written to determine if the target is not patched against MS17010. Additionally, it checks for other parts. So our major objective of this one is to simply check all the possibilities over there that could be lead us to information data part. So we're going to use this one in our upcoming sessions. But if you are using the SC command, which is by default command, it's a more advanced scan. Let me show you how does it look. Script scan. By default, you are using all the scripts in a single machine. And it's going to take some time. It's going to take a lot of time to scan the server. Okay, 1 second has been left. Okay, so we have okay, still we have 3 seconds left because this is an advanced scan and the output will be totally different. See, you will see an advanced proper scan over there. You can see the port number 20 was open, but it's showing it was anonymous access allowed. It was connected on the port number 110 on FTP server. 22 which is SSH, which is running over here, RSN and DSA algorithm. So how are we going to examine those things? It's all about the advanced script scan, and it's a totally aggressive scan first of all. Now for the OS detection, Nmap with a capital O for the OS detection over here. OS detection is just like your fingerprinting, identifying the OS type. And over here I can see it was in Linux with a version of 2.6.9 and so what I can see, I can check for the vulnerabilities over there. There are lots of vulnerabilities. There are around 8 vulnerabilities as a filter. See, it's all about to examine the type of attacks over there that could be lead us to different things. And some are DOS attacks mostly. Now what we have. Okay, time and techniques performance. Time and techniques performance are basically used to faster your execution, and they are from 0 to 5. See over here on my screen. The time and technique performance. The time technique is one of the best techniques to avoid firewalls and IDS. The idea behind this technique is to send the packet gradually so that can be used for the further stages detected by the firewalls. So they are from T0 to T5 and they are paranoid, sneaky, polite, normal, aggressive and insane. And each and every time and performance has a different kinds of your scanning part that could be help us for different things. For example, Nmap-T4 and IP address. Let's have a look over here. In a few seconds, a lot of packet has been generated. In a second, a few. The faster execution is based on the sending the packet in a gradually manner, in a proper manner. Let's see as T2. So it's going to send a packet in a simple, proper manner. That could be lead us that the scan has been done. See, our major objective of the scan is to check all the things one by one that could lead us to information gathering part. And see, it's going to take some time because the packet is been sending in a proper manner way that can be request and response. It's all about the fast scan. And each and every scan over there has a different functionality. The firewall thing, which we're going to learn in our upcoming session in firewalls, in our outcomes. Let's see the last thing, which is our output. If we have any server to scan on the server side, we have to save the output also. For example, if I'm doing Nmap, let's do capital small O capital N and name this one, save the output on the root desktop on the test file and the IP address. So the output, you have to save the output. You can see ON, which is from the normal part, OX for XML file, S for your normal script scan, script kiddies, or IGO for grepper files. Grepper files are used to fetch any file from subside. Or you can use capital small O capital A, 3 different major parts. Or you can use verbos also to check the files. So we can use -B to check the file if you can find anything on the server side. See, it will show you if he discovered some files on the server. So the major objective of this scan is to simply check all the possibilities one by one. That could be help us for the information gathering part. And the output is saved over here. See, you can make a proper presentation. But the major concern, when you know all the ports works in different manner, remember which is your target. You can do Nmap. I want to see the serviceless versions. I want to check the open ports. I want to check all the open ports on the server side, plus among with the operating system. I want the output in the faster execution. I want the output on a file save, which is on with the root desktop, and name this one Nmap and IP address. The last functionality they were talking about is you can use all the functions in a proper single timestamp. And this is going to take a lot of time because it's an aggressive with lots of options. There are many further stages can be happened over here that could be lead us to information gathering part. So you will see the output in 2 seconds. Remember, if you're doing the scanning part, you have to be patient because if you're scanning a large number of volumes, so it's going to take a lot of time. It can take 1 hour, 2 hours, depends on the organization's network. So our major agenda over here is to check the possibilities. Yep. See this one. It's gonna scan the entire port numbers, plus we find the ports and services version also, and what was running over there, and the operating system also. See, and the output has been saved over here on the desktop. This was I was talking about. Check all the possibilities and all the applications which can be worked over there to be lead and information getting right. And that could be help us in various techniques. And the last and the least, okay, there are lots of tabs over here. So let's close some of the tabs. So Nmap. So let's use Nmap, and we're going to use some miscellaneous now. We don't have to use all those functions. We can use the capital A, enable OS detection, version detection, script scanning, and trace out. But in the real life scenario, if you're in the real life field of organization, if you're using capital A, it's not available. It's prohibited over there. So if you use -A and the IP address, it's going to do all the simple scan that we have mentioned with the commands -SV for the services version, -O for the operating system, -P for the port scanning, and the time and execution part. So there are some various techniques can be used. Yeah, see, with the help of capital. So this was the Nmap CLI version that took us a lot of time to understand. Is it clear to everyone?
Yes, sir.
Yes, sir. Let's have a look of the GUI version, which is our Zenmap. So in the Zenmap, all the command has been given over there. Just you have to put the IP address, but you have to select the type of scan. You want to intent scan, and you can see the intent scan gonna use -T4, -A, and -B. If you use for UDP scan, the command will be changed. TCP port scan. Scan the all number of ports. Ping scan, quick scan, -TF, quick plus, regular scan. This is the normal scan part. So let's use intent scan, and the IP address isn't given. So this will be a GUI version when we can see proper hosts and services over here, and the scanning techniques. So the major objective of this Zenmap is to show you a proper output. Can you use it for the further stages? So you can see if they scan the ports number, you can see they have discovered some ports over there, and which can be lead us for a proper information gathering part. See, it's going to use the NSC script also. The NSC scripts. So this is gonna take some time. It's gonna complete the scan in a few time because it's gonna use the initialization the time part. So when you complete the scan, you will see a proper output will be given over there that can be lead us for the presentation of the company. Yes, there is one command that we were talking about. If we are sending a ping command to google.com, we were doing this one on the first stage. So now the TTL value is 118. So 10 packets have been lost. To trace the packet where the packet has been lost, we can use trace route. Trace route is a packet which works for analyzing the packet which is closed on the back end, and this works on an ARP protocol. 10 packet has been lost. The first packet was generated from the router 190, which is my gateway IP. Then you can see 10201, some stars over here. The packet has been lost in the third pipeline. And over here you can see these are the number of devices and my triple IPC, which is my ISP. Trace route command is identifying with the help of your TCP friends. The internal control message protocol is supporting protocol in the Internet Protocol Suite. It is used for network devices, including router, to send error messages, operations, information syndicating requested devices available for the host to RP. A trace route uses TTL time to live field for the IP headers and incremental the IP packets in order to determine whether the host is. The time to live value decreases every time it reaches a hop of the network device. We can use ICMP trace route, TCP trace route, and UDP trace route. So you can examine over here ICMP trace route. Microsoft Windows by default using ICMP trace route to identify. After a few hops, you will get a timeout which indicate that there is a device like IDS and firewalls that blocking the ICP request. For example, this was the same thing. And this is still scanning the server. So there are lots of other things that can be used over here for your sessions can be completed in a proper way. The most important thing is to examine the parts that could lead us to information gathering. You can see TCP trace route. Many devices are configured to block ICMP trace route. This their way are trying TCP and UDP trace route, as known as the layer 7 trace. TCP trace route by default available to backtrack and vessel Kali links. Or you can install this one. See. For UDP trace route, you can use trace RT and trace route. So there are further things, but our major objective was to simply understand how the scanning works, and this was all about your scanning part.